Hello class, tonight you're going to be taking notes on factoring and solving polynomials by grouping, but before we do that I want to go over some of our factoring techniques we did earlier with quadratics. So we're going to review factoring to solve quadratics. So remember, when we had a quadratic equation and a was equal to 1, we would solve this using the little puzzle where we drew the x, we put our c value here and our b value here. And we want to look for factors of 4 that would multiply to give us 4 but add to be 5. So our factors of 4 are 1 and 4 and 2 and 2, and the only one that adds to give us 5 are 4 and 1. We would write our factors as x plus 4 times x plus 1 here, set those equal to 0, and I will get x plus 4 equals 0, so x would equals negative 4, x plus 1 equals 0, x equals negative 1. So that gives me my x-intercepts, so I know that I would have x-intercepts here at negative 4 and negative 1, and my graph would go something like that. Okay? In the second example today, my a is not 1. So remember when we had a not 1, we would slide it down here and multiply, and I wind up with x squared plus 5x minus 6 equal to 0. So then I would want to look for factors of negative 6 that add to give me 5. So I would get a positive 6 and negative 1, because if I multiplied 6 times negative 1, that gives me negative 6. But add these two, I get positive 5. So my factors would become here x plus 6 times x minus 1 equals 0. And then set these, before I do that, before I set them equal to 0, remember my a is not 1 here, so I have to divide out the a, because we multiplied him through. Now we're going to divide him out. So this becomes x plus 2, because 6 divided by 3. 1 and 3 doesn't divide, so we slide this up. And this becomes 3x minus 1 equals 0. Set these two factors equal to 0 to get my x-intercepts. I get x equals negative 2. Here I would add 1, then divide by 3, and I get x equals 1/3 and x equals negative 2. So then I know that my y-intercepts would look something like here and here at negative 2. So then we would have a graph that looks like that. Okay? Alright, the third example I'm going to look at is we have a cubic instead of a quadratic. So remember, when we have something like this, we always have to check for a GCF. And I look here and I notice that I do have a GCF. So the GCF here between these three terms is x. So in order to start that, I'm going to divide every term here by x. So here I'm factoring out the x, so I put what I factor out on the outside of the parentheses. And x cubed divided by x is x squared. 2x squared divided by x is 2x. And then 15x divided by x is 15. Okay, so now I have the GCF. So now I want to factor what's on the inside. I'm looking for factors of negative 15 that add to give me negative 2. My factors of 15 are 5 and 3, so this would be negative 5 and positive 3, because that adds to give me negative 2. So this would factor out to be x times x minus 5 times x plus 3. Okay, so continuing on with setting these equal to 0, I'd have x equal to 0, x minus 5 equal to 0, and then x plus 3 equal to 0, which gives me solutions of x equals 0, x equals positive 5, and x equals negative 3. So that would tell me that my graph would look something, negative 3, like this. 1, 2, 3, 1, 2, 3, 4, 5. I'm crossing at negative 3, 0, and positive 5. I know I have a cubic, so my ends are going to be in opposite direction. It's positive, so I'm going to be down and up. So I'm going to be down on this side. I'm going to come through, go back through 5, and come through here. So that's what my graph would roughly look like. Alright, so that's the review portion of our notes. And then tonight for the video, I want you to finish up the rest of the notes.